Hello, my kiddos and kiddas. We are looking at trigonometry. I know it's super exciting. I'm really excited. You should be too if you aren't already. So, basic, we have an angle, some stuff that we probably should remember from geometry, hopefully. We have an initial side where our angle starts and then a terminal side where it finishes. Notice our little arrow is directing us on which way it's going. We have this little arrow here that says, I start in the initial side, and over there it points to our terminal. And then the point, which kind of puts together both of those rays, is called the vertex. When an angle is in standard position, that means its initial side, so the side that we're starting at, starts on the positive x-axis. And when things are coterminal, so we have two angles that are coterminal, it means that they have the same initial and terminal sides. I know what you're thinking. You're thinking, Miss Lloyd, doesn't that mean that it's just the same angle? And no, it isn't necessarily. So say that I have an angle that starts here, and then say it ends, it's a 45-degree angle like this. So nothing says that that angle has to start and immediately stop, like from one to the other. So what it means when it says coterminal is, okay, I could have started here on the exact same line, but instead of stopping at that terminal, I could go all the way around to the terminal side again. And so I've gone an entire 360 degrees and then the 45 degrees again. So this is 405 degrees here. I could also start again at my initial side and go the opposite direction. And when I go this opposite direction, this makes my angle negative. So this is negative 315 degrees. And I know this because putting 315 and 45 together would give me 360 degrees. And because I'm going in the opposite direction, I'm going clockwise, then that means that it's negative. So going counterclockwise means it's a positive degree, going clockwise is a negative degree. So when we're doing degree measures, we know our 90 degrees is that right angle, and so we have all of our degrees kind of in between there. So we were 30, 45, 60 are very important because they come from those special right triangles. And then I have my 60 and my 120 as the same color, same with the 240 and the 300, because these are all reference angles of 60 degrees. So they all kind of mimic the same x and y values, if you will. Same with the 30 and the 330, the 150 and the 210. And then our 45, and then the 135, and the 225, and the 315. And then we have our quadrants. Each of them are named. So we have our first quadrant is where x and y are both positive. We have where x is negative and y is positive in the second quadrant. In the third quadrant, both x and y are both negative. And in the fourth quadrant, x is positive and y is negative. And so they're numbered counterclockwise. So here we're going to find a coterminal angle with 55 degrees. So I know 45 degrees is going to be directly in the middle, in between my x and y axis. So 55 is going to be a bit more than that. And you don't have to be exact. I'm not asking anyone to get out their compasses and figure that out. We're just going to eyeball it. So I've got my 55 degrees. And so if it's coterminal, one thing that I could do is start from my initial and go all the way around an entire rotation before getting back to that 55. So because I've gone an entire rotation, that means I'm taking the 55 degrees and I'm adding one whole rotation is 360 degrees, which means this new angle is 415 degrees. So this is a coterminal angle. I could also, so this is one solid answer. This is perfectly, absolutely 100% correct and fine to do. Say you're having a bad day and you want to find a negative angle instead of a positive one, which is again totally fine, completely valid. Everyone is allowed to feel the things that they feel, especially right now during COVID. So that means that both this negative angle and the 55 make up 360 degrees. So what I do in order to figure out what this angle is I take 55 degrees and I subtract 360. And that is going to give me negative 305 degrees. And this is another perfectly fine solution right here. So you have two possible solutions. Actually, you have an infinite number of solutions because you could also like go two rotations. So you could have 55 plus 2 times 360 or 3 times 360 or 4 times 360. It just means that you've gone like 4 times around the circle before you finally get back to that 55 degrees. Same with when you subtract. You could subtract 360 like 17 times if you really wanted to. I don't know why you would, but you could. Negative 28 degrees. So because it's negative, I know I'm going clockwise. So I have my initial ray, my initial line. And then because it's negative, I'm going in the opposite direction that I normally do. So it's going to be just less than 30 degrees. Again, you don't have to be exact. I'm not going to sit there with a compass and be like, oh no, this is actually, as long as you're like in the ballpark, you're totally fine. So this is my negative 28 degrees. And so I could, if I wanted to find a coterminal angle, just find the positive version, which means I'm taking the 360 degrees and subtracting that negative 28. Or I'm taking negative 28 and adding 360 degrees. Either one of those works. And so I'm just going to find the one for this one. If you want to find another, that's totally fine. You could have done negative 280 and subtracted, negative 200. Why do I keep doing that? You could take negative 28 and subtract 360 degrees in order to get like an entire rotation. It'd be a larger negative number, but it would totally work. And then this last one, you can totally pause and then figure it out for yourself. What would be something that would work? And check it with my answer that I'm going to have once you unpause. So basically what I did here, because 384 is larger than 360 degrees, that means it went more than one whole rotation. So what I did was to get it into one rotation by subtracting an entire rotation, so 360 degrees. When I did that, I got 24, which is a coterminal angle. So even I don't have to go any farther than that. So complementary angles, these are two angles that add to give you 90 degrees. And then, so you just take both of the angles and you get 90 degrees. When you add them together, you could, if you have one and you know you're trying to find the complementary angle, you could subtract the one that you know from 90 in order to get the one that you don't know. We also have supplementary angles that add to give you 180 degrees. So you add them together, you get 180, you subtract one from 180 and you get the other. So whenever I was in school, the way that my teacher kind of helped me remember this is that complementary is a C and you can make a 90 out of C, and supplementary is S and you can make an 8 for 180. So just a little trick to remember it. It's not something that's super important and it's definitely not mathematical. But you know, it's a nice little trick if you want it. So when we're talking directions, like I'm facing north, south, east, west, that kind of thing, or I'm telling someone to go in a certain direction, we can also use degrees, minutes, and seconds. So when you are looking at longitude versus latitude, I'm going to stop. Those two things, when you're talking about a specific location of something, you typically have degrees and decimals. You can also use degrees, minutes, and seconds. And so it works very similar to hours, minutes, and seconds. So if I want to go from a decimal of a degree and get minutes, then I would multiply that decimal by 60 in order to get minutes. The same way I would multiply 0.5 of an hour by 60 in order to get 30 minutes. And we would do the same thing once you have the minutes. If you have decimals in the minutes after you've multiplied by 60, you can multiply by 60 again in order to get the seconds. And then because we're dividing, so if we're going from I have my minutes in seconds and I'd rather just have everything in degrees, then we can take minutes and divide by 60 in order to get from minutes to hours, or in this case, degrees. And if you have seconds, then technically you would divide the seconds by 60 in order to get to minutes, and then divide by 60 again in order to get from minutes to degrees. So you could just divide your seconds by 3,600 in order to get your degrees. And then you would add all those decimals together to the full number of degrees that you already had. So an example here, we're going to express our decimal of degrees in degrees, minutes, and seconds. So I already have my full number degrees, and I'm going to take my decimal and multiply it by 60 in order to get my minutes. And the minute symbol, we use a little tick at the top, and I still have a decimal here. So instead of that decimal, I'm going to do that 0.2 times 60 again to go from minutes to seconds. And then I do 2 ticks in order to denote that it is seconds. So these are things that we want to know. So we've got minutes and seconds, and of course our lovely little degree symbol. Make sure you label. This next one, we have our minutes and our seconds and our degrees, and they want me to put this into decimal form. So I have my 51 degrees to start with, and because I'm going from a whole number to a decimal, then I'm going to be doing 23 divided by my 60 instead of multiplying this time. This will be in degrees. And typically I would have to do 15 divided by the 60 twice, so I'm going to divide by 360 so I don't have to do it twice, working smarter instead of harder. And so adding all those together, I tend to do this in my calculator, and so that's why I have my little parentheses there as well. This is how you can plug it into your calculator. I get 51.3875 degrees. So not only do we have degrees as measurements for angles, we also have radians. So we know pi is 3.14159.265, and then it just kind of keeps going and going and going and going on for forever. So this is also the ratio of your circumference to the diameter of your circle. And so it's kind of how we look at the radians. So the radians is the arc length, so the part of the circumference divided by the radius, because we're going from the center to the edge, and we're not using the entire diameter. This is how we get those radians. It's your arc length divided by your radius. So here, typically we're going to use an angle, a degree of 1, and your arc length is going to be equal to the radius. That's not something that we really have to worry about right now, though. It gets like really complicated. So anytime we have 90 degrees, we have pi over 2. 0 or 360 degrees is 0 or a full 2 pi. Pi is going to be the same as 180 degrees, and 3 pi over 2 is 270. And then we have all of the angles in between. And so you can go from radians to degrees or degrees to radians using these conversions. So I like to think of it, if I'm in radians, then I know I have pi over something or something pi over something. And so in order to cancel out the pi's, I would have pi on the bottom. And then if I have degrees, if I'm going from degrees to radians, then I know I have some sort of degree, and so the degree would be on top and bottom in order to cancel out the degrees and leave me with pi, which goes with my radian. So then we are going to be working back and forth with both of these. These aren't something that you want to just go back and forth on saying, translating pi over 6 to 30 degrees every single time and then just understand what 30 degrees is. You want to be able to understand both. The pre-calculus teacher, who's kind of in charge of a lot of this stuff, gets very angry with me when I have kids just translate from radians to degrees, and he's like, no, they need to know radians. So I'm like, okay, so we're teaching you in radians. We're not going to go back and forth from radians to degrees and degrees to radians. I will show you how to convert them right here, but it's not something that we're going to do over and over and over again, because you guys need to understand what radians is to begin with. So here we're changing the angles from radians to degrees. This is degrees to radians. I don't know why that switched. So it's in degrees right now. We see the degree symbol, and so we want to change it to radians. I definitely got these switched around. My bad. So I'm starting out with 60 degrees. In order to get rid of the degrees, I'm going to be multiplying it by pi over 180 degrees. These are equivalent to each other. So this is why it just kind of changes form instead of changing it completely. So it's like I'm multiplying it by a certain type of 1. So my degrees will cancel out, and I will have 60 pi over 180. And then I just reduce the 60 and the 180 to pi over 3. I can do the same thing with my 320 degrees. Again, I'm in degrees and I want to go to radians, so I'm going to be multiplying by pi over 180. And then doing all my reducing, I end up with 16 pi over 9. This one, again, I switched it. My bad. This is what happens when I do this over break. All right, so we're going from radians to degrees. It has a pi symbol. There's no little circle at the top, so I know it's in radians instead of degrees. So that means I'm taking pi over 6 because I don't want the pi anymore. I want this to be in degrees. I'm multiplying with my degree on top and the pi on the bottom so that the pi's cancel out. And then I'm left with 180 degrees over 6, which will end up being just 30 degrees. And then we're doing the same thing with 5 pi over 3, multiplying this by 180 degrees over pi, because again, I want the pi's to cancel out. 5 times my 180 over 3. Again, there's degrees in there, and I end up with 300 degrees. Next, we're finding an angle that is coterminal to negative 4 pi over 3. So this negative has the same rule as when it's in degrees. It means we're going in the opposite direction, so we're going clockwise instead of counterclockwise. Again, my initial is always starting on my positive x-axis, and then I'm going in the opposite direction. So my over 3, this is something that you can always like look at, you may need to look at those to begin with. My 4 pi over 3 is normally in the third quadrant, but because it's negative, that means it's going to be switching to the second quadrant. So I'm going that far. Normally I would go from my initial side, my positive x-axis, go through 2 entire, it's more than a full pi, but not quite pi and a half, I guess we can say. So I'm going a full pi, but not quite pi and a half. That one. So that means I'm going to be over here, again, going in that direction because it's negative. So this is my negative 4 pi over 3. And so I can just use the positive direction in order to find one that's coterminal, so then I don't have to do much. So then I'm taking my 2 pi and subtracting my 4 pi over 3 in order to figure out the positive version of that. And this is going to end up giving me 2 pi over 3, which is the same position that it's in whenever I look at my little drawing that I had up above. So then we're also going to look at the complement. So complement, we want to remember, adds to 90 degrees. That is the same as pi over 2. So remember, these two are the same thing. One's in degrees and the other one is in radians. So that means I'm trying to figure out what 3 pi over 16 adds with in order to get pi over 2. So then that means I can just take pi over 2 and subtract my 3 pi over 16. So that means I've got, what if I'm doing 16, and that's 8 pi over 16 minus 3 pi over 16. So then I've got 5 pi over 16. Next we are looking at the supplement. So remember that adds to 180 degrees, which is going to be the same as just pi. So that means I'm taking my 5 pi over 12 and adding it to whatever my supplement is in order to get pi, which means I can subtract my 5 pi over 12 from pi, and I end up with 7 pi over 12. The last thing we're going to look at are arc length and area of a sector. So arc length, it means that we're trying to find the portion of the circumference for a circle. Also, remember that the definition of a radian was the arc length divided by the radius, and this was in radians. So the angle of the radian is the arc length divided by the radius. So I basically just multiplied the radius to both sides in order to get this formula here. But because of this, that means that my angle has to be in radians. I cannot use degrees. You don't use degrees or things are going to, well, not explode, but it's just going to be wrong because this is in radians instead of degrees. So if someone gives you degrees, you have to change it to radians, which is just another step. Hopefully they don't do that. But oh, I see a little degree symbol right there, so it looks like we're going to have to do that. And we're finding the area of the sector, so the stuff that I have shaded in blue here. So it's like the amount of pizza versus the crust. So the arc length is the crust of your pizza, and then the area is like all the cheese and the gooey goodness of the sauce, and I'm really hungry now. Anyway, so in order to find the area of the sector, we're doing half times radius squared times the central angle. And again, the central angle must be in radians. Must be in radians. Radians. You're gonna have nightmares now. All right, so for this first example, they tell me that the radius is 27 inches. They want me to find the length of the arc, so they want me to find my arc length. Length of arc is the same as arc length, so we're trying to find S. And they tell me that my central angle is 160 degrees. So again, I know that I can't actually use degrees, so I need to change this into radians. And I end up with 8 pi over 9 radians. So now I can do the darn thing. And when I do my multiplying, so there are a few different ways you could write it down. It depends on like who's asking the question and what it is they want. So typically I don't like to mess with the pi, so I just leave it as pi and I do the 27 times the 8 divided by 9 and you end up with 24 pi radians. If you have the pi there, you don't really have to specify radians. You could in your calculator, instead of pi, put 3.14, and so we would end up with 75.36 inches. So if you're talking about actual measurements, that should be inches, sorry. We're talking about length. Length is not in, that's the angle is in radians, and then the length is in the measurement. So it said inches, we're working with inches. Anyway, if you're talking about actual measurements, there's not a contractor on the planet who's going to be like, oh yeah, 24 pi inches, I totally know how much that is, and I'm going to like make it exactly that. No, they're going to be using decimals like 10 out of 10 guaranteed. So you might as well write it in decimals because that's what most people talk in. Actually going to save this for my students because I want to torture them by making them do the sprinkler. So if you're my kid and you're watching this, fun fact, you're going to be doing the sprinkler next class. Do. I hope you guys have a wonderful day. If this was helpful and you feel like it could help someone else, then please feel free to share this. Maybe like and subscribe while you're at it. Spread that love.